Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Keam Prep, we're going to be looking at some questions asked in previous years of the Keam exam. So this particular episode looks at Keam 2020 and some questions which were asked in that exam. Let's start off with our first question. This one's on mathematics. Let A be the set 2, 3, 4, 5 and B be the set 36, 45, 49, 60, 77, 90. And let R be the relation is factor of from A to B. Then the range of the relation R is the set of 60, set of 36, 45, 60, 90, set of 49, 77, D set of 49, 60, 77, and E the entire set B. So, which of these is the correct option? Well, element of A is a factor of element in B. So that means the elements in B must have a factor that is present in the set A. So let's look at 36. So 36 can be written as 6 squared, which is 6 times 6. So 6 can be written as 2 into 3 times squared, so therefore it's 2 squared times 3 squared, and since 2 squared is 4, you can write it as 4 times 3 squared as well, since we have both 2 and 4 in the set A. So 36 is contained of factors 2, 3, and 4. Now, let's look at 45. 45 can be written as 5 times 9, which is 5 times 3 squared. So therefore, 45 is also made up of factors belonging to set A. What about 49? 49 can be represented as 7 squared, but unfortunately 7 is not present in the set A, so therefore 49 cannot be present in the range of this relation. Now what about 60? Well, 60 we can write that as 6 times 10, which is 2 times 3 times 5 times 2. So basically you have 2 squared times 3 times 5 as the expansion of 60. So 60 has factors in 2, 3, 4, and 5. So therefore 60 belongs to the range. 77 is made up of the factors 7 and 11. 7 times 11 is 77, and 1 times 77 is 77. So therefore, since its factors do not belong to the set A, so 77 does not belong to the range. And finally, you have 90, which is 9 times 10, that is 3 squared times 5 times 2. So therefore, 90 also belongs to the range of the relation R. So therefore, the terms that belong are 36, 45, 60, and 90. If you look at our options, you can see that option B, 36, 45, 60, 90, is the correct set that represents the range of the relation R. So therefore, option B is the correct option. Now let's look at this question. If A is 1, 2, 3, 4, is the set containing the elements 1, 2, 3, 4, 5, and B is the set of elements containing 2, 4, and 6, then the set A minus B is 1, 3, 5, 6, 0, 1, 3, 5, 6, 1, 3, 5, 1, 2, 3, 4, 5, 6, 2, 4. Well, we know of set A and set B. Now notice that both A and B have 2 elements in common, which are 2 and 4 respectively. So therefore, if you were to define a set A intersection B, then this set will contain the elements 2 and 4. And why do you think that we are defining A intersection B? Well, because the set A minus B can be represented as set A minus the set of A intersection B. So therefore, we can now, write the set A, 1, 2, 3, 4, 5, and subtract the set 2, 4 from the original set. So basically the definition of A minus B is the elements which are present in set A but which are not present in set B. So an element can be present in both set A and B if they are part of the intersection of A and B. So if you remove the elements of the intersection from the original set, you will get 1, 3, 5 as the elements of the set A minus B. So therefore, the correct answer among the following is option C, the set 1, 3, 5. 1, 3, 5, 6 is incorrect because 6 is not present in the set A. 0 is not present in the set A, so option B is incorrect. And here you have 2 and 4 which are present in set B, and 6 which is present in set B but not in set A. So option D is basically A union B, which is not the correct answer we're looking for. And 2, 4 refers to A intersection B. You can't write that as the answer, but you can use this set to find out the answer, which is A minus B. So option E is incorrect. The correct answer is option C. A minus B is the set containing the elements 1, 3, and 5. Now let's look at some questions of physics. If the distance between the sun and the earth is d, then the angular momentum of the earth around the sun is proportional to under root of d, d squared, d raised to 1 by 3, d raised to 3 by 2. So in orbit, we find that the angular momentum is conserved. So we can write angular momentum L as m times v times r. So what we're going to do is we're going to apply the value of v, which is orbital velocity. So that means v equals under root of g m by r. Now r in this case is the distance d, so therefore it is m times gm by d under root times d. So therefore, you know, d raised to 1 divided by d raised to 1 by 2, so that's d raised to 1 minus 1 by 2, which is d raised to 1 by 2. So therefore m times under root of g capital md is the value of the angular momentum. So therefore the angular momentum of the earth orbiting around the sun is directly proportional to the square root of the distance between the sun and the earth. So therefore the correct answer is option A, under root of d. Now let's look at another question of physics. The ratio of the weight of a body at a height of r by 10 from the surface of the earth to that at a depth of r by 10 is. Now you can consider capital R as the radius of the earth. Well, in order to compare these two values, we have to first use the formulae for the acceleration due to gravity at a height h and the acceleration due to gravity at a depth d. So acceleration due to gravity at a height h can be written as g times 1 minus 2h by r. So that is g times 1 minus 2 into r by 10 divided by r. That equals g times 1 minus 2 times r by 10 is r by 5. So that is r divided by 5r. So what we get inside the bracket is 5r minus r divided by 5r times g. So therefore 4 by 5 g is the correct, relation between g and g at a height h. So therefore gh is equal to 4 by 5 times g. Now let's look at how to find acceleration due to gravity at a depth r by 10. So that is gd equals 1 minus d by r. 1 minus d by r. So we are going to substitute those values, 1 minus r by 10 divided by r. So therefore g times the denominator is 10r, and then the numerator is 10r minus r. So therefore g times 9r by 10r eventually leads to the relation g at a depth d is equal to 9 by 10 times g. So now we know the acceleration due to gravity at a height of r by 10 and at a depth of r by 10. Now we are going to assume that the body has mass m. So we need to find the ratio of the weight of the body from the surface, weight of the body at a height from the depth. So therefore basically what we are calculating is weight at our height r by 10 divided by weight at a depth r by 10. So that is equal to m times g of h divided by m times g of d. So you can cancel the m's, the masses, because we're looking at the same body. So it's basically gh divided by gd. So that is 4g by 5 divided by 9g by 10. So you can cancel the g's out, and we can write this same relation as 4 by 5 times 10 by 9. So 5 goes into 10 twice. 4 times 2 gives you 8. So the correct answer for the ratio of the weight of an object at a height r by 10 to the same object at a depth of r by 10 is 8 divided by 9. So from the given options, it is clear that option E is the correct option for this question. Now let's look at some questions. This time it's of chemistry. The rate constant of a first order reaction is 231 times 10 raised to minus 5 per second. How long will 4 grams of this reactant reduce to 2 grams? So we are going to use the integrated rate equation of a first order reaction. So now we're going to write T as equal to 2.303 divided by K times log of A naught, concentration of A naught divided by concentration of A. So this is the integrated rate equation, and what we're going to do is we are going to find out the time period, and we know the rate constant, we also know the concentrations. So what we have to do is just plug in the values. So the time T here will be equal to 2.303 divided by 231 into 10 raised to minus 5 second inverse, and then you have log of concentration of A naught is the original concentration, so that's 4 divided by the final concentration, which is 2. So what are we getting? T will now be equal to 2.303 times 10 raised to 5 divided by 231 times log 2 seconds. So since we're calculating the time, the unit here will be seconds. So the reason why 10 raised to minus 5 goes to the top is because it's under a denominator. So 1 by 10 raised to minus 5 is 10 raised to minus of minus 5, which is 10 raised to 5. So it's now present in the numerator. So what are we going to do? The value of log 2 is estimated to be 0.3. Now if you want to learn more about how logarithms can be estimated without referring to a log table, then don't forget to watch our video on how to find log within 15 seconds. I'll put the link below the description. Let's look at this question now. So we'll now add in the value of log 2. So that is equal to 0.3. So we have 10 raised to 5 here, and we can use that to try and simplify the decimals that we have. So 2.303, in order to convert that into a whole number, we have to multiply that by 1,000. So you can take 10 raised to 3 off from here. So you have 10 raised to 2, that's 100 remaining. 100 times 0.3 gives you 30. So basically you have 2303 divided by 231 into 30 as the answer. Now 2303 divided by 231. Let's start dividing. So 231 does not go to 230, so therefore we have to divide everything. And 231 times 10 is 2310, which is bigger than the numerator given here. So the best thing to do is 231 times 9. 1 times 9 is 9. 3 times 9 is 27. 2 times 9 is 18. 18 plus 2 gives you 20. So 2079 is what we get. So let's put in 9 at the quotient. So we have to subtract that. 3 minus 9 does not work. It has to be 13 minus 9, which is 4. So we have to borrow from this 3 here, because 0 doesn't have any value. So this becomes 2. The 0 becomes 10, which then becomes 9 in order to borrow that to 13. 9 minus 7 gives you 2. 2 minus 0 gives you 2. And 2 minus 2 gives you 0. So you have 224. Now 231 does not go into 224, so we put a point there. So now we can add zeros. So this becomes 2240. Again, bigger than 231 times 9, so 9.9. And then you would put in 2079, so it's 10 minus 9 is 1. 13 minus 7 gives you 6. 1 minus 0 is 1. And 2 minus 2 is 0. So you get 161 as the remainder. Now, this is approximate, so we have something 9.9 something will be the answer, times 30. So what we can do is, approximate 9.9 to 10. So now we have 10 times 30 as the time taken. So therefore 300 seconds is the correct amount of time that is required to convert 4 kg of a substance to 2 kg under the given rate constant. So therefore the correct answer is option B, 300 seconds. So therefore what we did was we put in the integrated rate equation. T equals 2.303 divided by K times log A naught divided by A. Both of them are concentrations. And the simple thing that we did was put in the values, and then we get a log 2. Log 2 can be found easily once you refer our other video on how to find log in 15 seconds. So now we know log 2. And then also put in the values. So everything's put in. You just have to divide 2.303 divided by the rate constant, and you'll get your answer after simplification to be option B, that is 300 seconds. Let's look at the final question of this episode. An endothermic reaction, A to B, has an activation energy of 13 kilojoules per mole, and the enthalpy change for the reaction is 2 kilojoules per mole. The activation energy of the reaction B to A is it 15, is it 11, is it 2, or is it minus 15, or is it 26 kilojoules per mole? Now, we know that the reaction here given is endothermic, so let's draw a graph. I find that pretty easy to solve this question. So energy is on the y-axis, and you have the reaction coordinates on the x-axis. So now let's say we have a certain energy for the compound A, and it's undergoing an endothermic reaction. So when it undergoes an endothermic reaction, energy gets released. So therefore, while the energy of the point B is greater than that of A, it actually passes a peak before coming down. Now, the activation energy of this reaction is the difference between the point A and the peak Now let's write that as x for the time being. And since we also find that B has a certain level of energy, the enthalpy change for this reaction will be the difference between A and B, which we can write as Y. We know that X equals 13 kilojoules and Y equals 2 kilojoules. So, this is when the reaction is from A to B. Now we want to take the opposite reaction. We want to take it from B to A. So that means the energy first goes up to the peak and then it starts decreasing rapidly. So this is actually what we get as the activation energy, which is Z. So it's from B, energy of B to the peak, so that amount of energy is what we call Z. And we know that Z plus Y equals X, so therefore Z is equal to X minus Y. So the value of Z is 13 minus 2, which is equal to 11 kilojoules. So that means among the 5 options, it is clear that option B, 11 kilojoules per mole, is the correct answer for this question of chemistry, which was asked in Keam 2020. So the main idea is to draw the energy graph for an endothermic reaction, find out the exact values of the activation, find out the values of the activation energy and the enthalpy change in that graph, and then we knew both those quantities for the first reaction, which is from A to B, and now for the reverse reaction, which is from B to A, we just have to find the energy between B and the peak energy of that reaction, which was Z, and we could find that out as X minus Y. So Z happens to be the activation energy of the reaction B to A, so 11 kilojoules per mole is the correct answer. So that's 11 kilojoules. Now, we hope you found this episode interesting. For more of our videos, don't forget to subscribe to our channel, which is Brain Blitz Audios. And if you want to learn more about Keam and access more previous year questions, don't forget to hit the playlists, whose link is given in the description box below. If you want to get latest updates from our channel, then don't forget to hit the bell icon, which is again present below the video. We've also made a video on how to find logarithms fast for competitive exams such as these, so therefore don't forget to access that video as well. Its link is given in the description box. So until the next webisode, take care, stay safe, practice a lot of questions. Bye-bye for now.